Hello everybody, welcome to Lab 7 of Artificial Intelligence. This lab focuses on the inference rules of propositional logic. In pre-lab, you need to explain the different types of logics in brief. And the other question that you need to answer is, you have to list the names of inference rules of propositional logic, and you need to list out the properties of the propositional logic. That's the pre-lab you ought to do before coming to the lab 7. And to carry out the in-lab, you should have a short overview on inference rules. Inference rules are the templates for generating valid arguments. See, this we need to stress on. We need to generate valid arguments. So these rules are applied to derive proofs in artificial intelligence, and the proof is a sequence of conclusions that leads to the desired goal. So we need to write down a sequence of steps or conclusions in order to meet our goal. In inference rules, the implication among all the connectives plays an important role. Following are some terminology related to inference rules. So we normally call implication. Implication is something like a logical connective between two objects, P to Q. We normally call it as Boolean expression. Converse. The converse of implication, that means it's the vice versa of the implication, which means the Q comes on to left and the P comes on to right. This is called as converse. Contrapositive. This is the negation of converse. So if you negate the converse, we obtain the contrapositive, that is not Q tends to not P. And the negation of implication is the fourth rule, which is nothing but the inverse, which specifies not P tends to not Q. There are certain important definitions as far as inference rules are concerned. Argument. What is an argument? An argument is a sequence of statements. We also call it as premises that end with a conclusion. So we need to that conclusion is our goal. Validity. It's a deductive argument. A deductive argument is said to be valid if and only if it takes a form that makes it impossible from the premises to be true and the conclusion nevertheless to be false. The conclusions which you are going to draw would never be false from the premises if the premises are true. So that's what validity is. And fallacy. This is an incorrect reasoning or mistake which leads to invalid arguments. That we call it as fallacy. And the structure of an argument normally will have a sequence of statements which we normally call it as premises that end with a conclusion. So this is a short overview on inference rules. So in lab 1 you are given a list of inference rules. Kindly watch. Mammal A tends to vertebrate A, vertebrate A tends to animal A, and vertebrate A, flying A leads to bird A. Besides these three, we also have certain other rules: vertebrate duck, flying duck, mammal cat. Translate those rules into a Python code. So from this, we need to obtain this setup. This is how the output should look. So we see from these given 6 inference rules, the last 3 rules, we can definitely say a duck is a vertebrate, duck flies, cat is a mammal. See, vertebrate duck, flying duck, mammal cat. So you need to find out certain other inference rules based on these facts and given this set of inference rules and add them to the initial list of rules. So a Python code is to be written. I'll give you a small hint for this. How should they see the procedure? We have these initial facts: vertebrate duck, flying duck, mammal cat. So we need to generate a list of lists. So that's the initial set of facts that we need to identify from the given set of inference rules. So what should be the processes from the remaining inferences? In this case we have these remaining inferences. From this we need to obtain any other possible facts that can be derived and add it to the existing list. So the final output would be, we need to be printing all the facts as list of facts. So initial list of facts in this example consists of vertebrate duck, flying duck, mammal cat. Now from these we need to derive certain other things. For example, if I say mammal A leads to vertebrate A. Suppose if I say A is a cat, So then I say mammal cat leads to vertebrate cat, and this vertebrate cat leads to animal. So what does it say? Cat is an animal. So animal cat. So this is added to the existing list. That's how you have to derive the other inference rules. So for that you need to write down the Python code, and this is the hint that can be used. And in the second in lab, you are given a set of axioms and you need to solve them. What do you mean by solving them? Means you need to represent them as the rules using the unification. So anyone whom Mary loves, whom Mary loves is a football star. Any student who does not pass does not play. John is a student. Any student who does not study does not pass. Anyone who does not play is not a football star. The conclusion is, if John does not study, then Mary does not love. So we need to be writing those inference rules. So I'll tell you one thing, reminding you need to be writing on your own. See, for the first one, anyone whom Mary loves is a football star. So here I consider Mary as things. Anyone, I'll represent that as X. X represents anyone. Anyone whom Mary loves is a football star. So this X contains anyone. It could be a football star or it could be anyone. So loves, Mary loves this person that belongs to this X. So loves Mary, comma X is star X, because if Mary loves, definitely that person is a football star. So the total thing is embedded into for all. So we write it as for all X loves Mary, comma X implies star X. In the similar manner, you need to be writing down the statements for or the inference rules for the remaining ones. Coming to the post lab, here this is the question given. After teacher explained about inference in proportional logic topic, then Sita gave these problems to her friend to test her capability, help her to solve the problems. So what does this first one say? If I eat spicy foods, then I have strange dreams. I have strange dreams if there is thunder while I sleep. I did not have strange dreams. So certain things we need to identify from this. I eat spicy foods is one thing. I have strange dreams is another thing. There is a thunder while I sleep. I did not have strange dreams. So I have strange dreams, that can be negated and you get it as I did not have strange dreams. So we need to be generating all the possible inferences from this. Similarly for the second question, I am dreaming or hallucinating. I am not dreaming. If I am hallucinating, I see elephants running down the road. Again, I am dreaming. That's one thing. That's one premise. I am hallucinating is another premise. So I am not dreaming is just a negation of I am dreaming. If hallucinating, then definitely I see elephants running down. So I see elephants running down the road is another premise. So we need to be writing down those statements for these two problems. And I'll give you a small hint. We need to use this inference rules. See here, there is one table, rules of inferences, which consists of modus ponens, modus tollens, hypothetical syllogism, disjunctive syllogism, addition, simplification, conjunction, resolution. We can be applying any of this. So you need to initially identify the premises and then apply this in rules of inference and generate. Similarly, you can also use this second table, rules of inference for quantified statements. See, for all X that can be used. So universal instantiation. Similarly, universal generalization, existential instantiation, existential generalization. So using these hints, you should be writing as the solution for these two problems as part of post lab. So this is the end of lab 7. Thank you.